Bună dimineața. Thank you. Just a few things before we get started. There will be no slides for you to take a photograph of, don't worry. If you want to remember something about what I say here today, then you can always go to this link at the bottom, easypart.jbrains.ca. That provides a summary of the talk. By the way, you can also go here if you want to ask questions. I will try to leave time to answer them on stage. And it avoids this, awkward thing of someone handing you a microphone, then you have to say your question in front of everyone, and then we have to wait, and I have to ask you, blah, blah, blah. You just type the questions in here, and if I don't answer the question on stage, then I will answer the question online at some point in the future, probably later today. That's my promise to you. You can be guaranteed. One last thing. I have nothing to do with JetBrains. I'm JBrains because that was the beginning of my name. When I started working at IBM in 1998, we still had VNet. You don't know what VNet is, and that's good, but you could only have 8 characters for a login name, so I chose the beginning of my name, and I ended at the syllable line, and my manager said, "Oh, JBrains, that's cute." And from that moment, I was JBrains. So, what I'd like to talk about this morning is programming is the easy part. Now be careful. I don't mean it that way. I don't mean it that programming is a trivial matter. I don't mean that programming is not important. And I certainly don't mean that programming on its own is easy. But compared to the other aspects of our work as software professionals, one of the things that I learned after a few years of practice was that, indeed, programming really is the easy part. Now, it's the easy part in 2 ways. It's easy compared to the other things that we need to do, but also I find that programming is actually relatively easy to master. Now, I say that, and some of you get a bit worried. So when I say master, probably my bar is a little bit lower than yours. So let me say it a different way. I think that with a few basic rules and 3 to 7 years of practice, you will perform better than 95% of the programmers around you. And that maybe has more to do with the fact that the bar is a little bit low than it does about how powerful my techniques are, but I think both are true. And I recognized one thing when I started to work, that as I was learning some things to try to make my job easier, to make things work better for me, I started to notice that I was probably producing 2 or 3 times as much value as the people around me, but I wasn't earning 2 or 3 times the amount of money. And I thought perhaps that was a little bit of an imbalance to keep in mind. And what that did was that allowed me an opportunity to take advantage of my situation and to spend more time learning. One of the hardest things that one of the things that we fall prey to, I think, as programmers, is we assume that we don't have time to learn things because we're too busy producing all the time. And one of the things that I want to share is just a few ideas about how you can find some spare time to learn. Yes, you already have it, you're just wasting it now. And if you use that spare time to learn, then you can give yourself even more spare time to learn, and this becomes a virtuous cycle that leads to all kinds of nice benefits. In the best case, either you become one of the most respected people around you at work for the level of quality that you produce and for the way that you do your work, or maybe slightly less, you produce 25% more than the people around you, which is enough to keep your manager and their manager and their manager happy, and you spend lots of your spare capacity learning whatever makes you happy. So how do we get there? I think the centerpiece of doing good work as a programmer lies, oddly enough, in evolutionary design. So what do I mean by evolutionary design? This is a style of design where you act like the code is trying to evolve. The code is changing, almost like it's doing it on its own. But you are acting like the God who is guiding its evolution. You are acting like the fitness function. You are the one who decides which code lives and which code dies. And by following a few relatively simple rules and by practicing a lot, you can actually guide code to move in a direction that benefits you. So evolutionary design, that's the evolutionary part. But what does the design part even mean? I bet if you go around to the best senior programmers in this room and you ask them what they mean by design, they might not be able to tell you. This is one of those words that senior programmers like to use to smack junior programmers around in the head a little bit without really having a clear picture of what it is that they mean. So for me, design really comes down to how do we organize the code in order to change the cost of changing it. When we all we're doing when we design is organizing the code. 20 or 30 or 40 years from now, when computers are designing software for us, or when they're building software for us, really they'll just be generating code for us. When they become powerful enough to be able to do that and take our jobs, it's coming. I just hope it happens after I'm dead. I don't think computers will ever need to design anything. I don't think computers will need to do software design in the way that we think of it. Because if a computer has difficulty changing the code that they've written, they're so fast that they'll just throw it all away and write it again. There'll be no need for them to design or organize code, because there's no reason for them to read the code that they've already written. They can just make it again. But we can't work that way. We need to design systems, which really just means organize the code so that we can understand it later. And that's literally all that design is. Design is about organizing the code so that we understand it later. And that matters because we are constantly trying to reduce the cost of changing the code. That is what the programmers, the true programmer's job is. Not just to make things work, not just to pound on the keyboard until the behavior seems correct, but to write the code and organize it in a way that they'll be able to change it later without paying too much cost. And evolutionary design is an approach that relies on the idea that instead of trying to, at the beginning of the project, imagine the perfect way to organize all the code and then lay out these nice boxes in a perfect line, and then I put this kind of code here, and I put this kind of code here, and I put this kind of code there, to instead think of it a little bit more like the way that you organize things in your house. So if you're like me, in your house somewhere is something that you'll call a junk drawer. It's a good name, it's a drawer with junk in it. And it's the drawer where you just throw everything in there without trying to organize it. Maybe you throw some pens and some leftover twist ties from bags you get from the grocery store, and there's some elastic bands in there and some paper clips and some stuff, and you don't really know when you're going to need any of those things. But you have to put them somewhere, so you put them there. Usually it's in the kitchen somewhere. And you just put stuff in there. And then gradually you start to notice that you start to need paper clips a little bit more often, or you start to look for a particular pen and you have difficulty finding it. And as soon as you realize that you're looking for something specific and you're having difficulty finding it, then that's the point where you say, I've done this 3 or 4 times now. Now's a good time to have a special place for this pen that I care about. Or to have a separate drawer for the paper clips, or a separate drawer for the elastic bands, because I'm using them more often. So then you go and you find another drawer in your house, you clean it, you feel nice about it, you draw some diagram, or you have some little picture or words on a sticky note, or you get out your label maker and you put a nice label, elastic bands. And then you go through your junk drawer and you find all the elastic bands once. It's annoying, it takes 10 minutes, but you do it. You find them all, and then you put them carefully in the elastic bands drawer, and then you make an announcement to the house. From this day forward, when you have an elastic band and you want to put it somewhere, put it here. This is the special place where elastic bands go. Please put it here. All the rest of the crap, put it in the junk drawer like we've been doing. What you did here is evolutionary design. You used an opportunity to, first, you pretended that you didn't need a special drawer for elastic bands. And then you lived that way for a while until it started to become a problem. And then once it became a problem, you decided to do something about it. The nice thing about evolutionary design is that you can follow a few simple rules. I don't have to know at the beginning which things are going to go in which drawers. I don't need to make a bunch of rules on the first day that we move into the house. And say, okay, well, I don't know anything about this house. I don't know anything about how my family is going to operate, but I do know that pens will go here, and paper will go here, and elastic bands will go there, and you don't know, you have no idea whether any of this will work. With evolutionary design, you're adopting the idea that instead of deciding where everything should go, you have rules for figuring out when you need to add structure and how to do it. And the rules that I use in code, I started with the 4 elements of simple design. I won't describe the whole thing to you. It's in the notes. Read it at your leisure. And in fact, what I realized about the 4 elements of simple design is that I don't even need all 4 of them. So very quickly, the 4 elements of simple design say this. When we say simple, we mean design that passes the tests, has relatively low duplication, expresses its intent very well, and isn't too big. And the first element is more important than the second one's more important than the third's more important than the fourth. And that's it. If you follow these rules, as you follow these rules, then the design magically evolves to be wonderful. And that word magically always made me nervous. It seems to work, but I didn't really understand why. And my good friend Corey Haynes, who is sort of me, but with a Rails background, he always used to say, no, you're wrong. You want to pass the tests, you want to express intent, don't repeat yourself, and then make it smaller. You'll notice that the second and third elements, that I put them in this order and he puts them in that order, and I was certain that I was right and he was wrong, and he was certain that he was right and I was wrong, and we couldn't figure out how that could possibly be because both of us were getting good results. Until one day it hit me. So this is really how removing duplication and expressing intent work together. And to me, this is the nucleus, this is the centerpiece of good evolutionary design. So you have code somewhere. And you start to notice that there are some things duplicated. It could be as simple as exactly the same 4 lines of code are in 12 places. And you know this is a problem because if you have to change those 4 lines of code, you will change 11 copies, you will forget to change the 12th copy, there's a bug. Or worse, you'll fix a bug, and then 3 weeks later somebody will report the same bug in a different place, and you fix it there. And then 2 weeks later somebody will report the same bug in a different place, and you fix it there. And maybe you learn in 1 year that you finally got all of them, but you never feel very secure about it. It could be more like this code has the same structure as this code, but some of the values are different. Or this code has the same general purpose as that code, but some of the implementation steps are different. It could be any kind of duplication. If you remove that duplication, what you're doing is exactly the same as looking through your junk drawer and grabbing all the pens. You're recognizing that maybe there is something in this code that wants to be expressed in one place. Something that I'm doing in many places, and if I copy and paste that code, then things will diverge over time and the behavior will be more difficult to understand and predict. It would be better if I had this in one place. So you remove the duplication. You extract something. You create new functions, new methods, new namespaces, new modules, new subsystems. It could be at any scale. But when you remove duplication, what you're doing is you're creating a new structure. You're creating a new container. It's like deciding, aha, I need a new drawer in my house. And the nice thing about working with software is that you can create as many new containers as you want. There's always room for more. Disk is cheap. So when you create this new container, now there is one place to express or to implement this one thing that the system needs to do. It's in one place. We know that that behavior will be consistent. Every time you call it, it will do the same thing. So that's nice. We've removed the duplication problem. But when we create a new container, a new class, method, function, whatever it is in your programming language or your programming paradigm, you have to give that thing a name. And we're programmers, and we don't name things very well. We have to help each other a lot with names. Naming isn't really that hard. What's hard is that we don't practice naming things. We just type some characters and we assume that's the name for the rest of our lives. And it doesn't have to be that way. When you name things, so when you create a new thing, you have to give it a name. We're programmers, we're not very good at naming things, so we need to help each other. So we need to have a way to improve the name over time. And every time I see a name that doesn't quite fit, I'm thinking about how to make it better. I'm using my emerging knowledge of how the system works, my emerging knowledge of the domain, my emerging knowledge of the application, the technology, to make that name better over time. And as I make those names better over time, something very interesting starts to happen. If I have a very consistent way of naming things, even if it's not very good, if it's consistent, and there are some tricks that I can teach you, there's a link to a little diagram in the notes. When you name things consistently, you start to notice patterns in the names. You start to notice that these three parameters to this function have similar words in the name, so maybe they belong together in a little object. Or I notice that the same name is being used in the code in 5 different places, and as a good rule, if the names are similar, you should move that code closer together, and if the names are different, you should move that code further apart. This is related to what Larry Constantine called cohesion. So if you know the whole coupling and cohesion principles in software, cohesion could be as simple as put similar things closer together, put dissimilar things farther apart. The idea here is that if things are similar and they're close together, then when I change one, I probably need to change the other ones, and they're all here, so I can see them. And the reason to put different things far apart is that if I change something here, I don't want to by accident change something that's not related. So I want the unrelated things to be farther apart so I don't accidentally change them. And I want the similar things to be closer together so I can see them when I'm looking here. This sounds like something that might be helpful in changing code. When you name things and you move similar things closer together and different things farther apart, then as we move similar things closer together, we start to notice that we can extract abstractions from those things. Abstraction is another one of those words that senior programmers throw around to hit junior programmers in the head, but when you ask them what is abstraction, maybe they don't know. So here's a definition I propose. Abstraction means hiding details. That's it. Some abstractions can be helpful, some abstractions could hurt, but what you're trying to do is to hide details. If you look at code and you have to look at 4,000 lines of code with detailed implementation all at once, your eyes just glaze over and you can't see anything anymore. But what would happen if I could take 80% of that code and let it fade into the background and you just look at the 20% that's left and you still understand what's happening? Maybe not every detail, but you understand enough to know what's going on. Think of how much easier it will be to understand that code if 80% of the details could just fade away. You don't need to know those things now. You can start to see higher level patterns. You can start to see duplication at a higher level of structure. Well, that's interesting. If I remove duplication, I create containers, and then I give those things names, and those names help me move similar things closer together and different things farther apart. And as I move similar things closer together, I see abstractions. 80% of the details disappear. And now that I'm looking at less code, I can see bigger forms of duplication. But then if I remove that duplication, I create new, bigger boxes, which need names. I give them names, similar things closer together, different things farther apart. 80% of the details fade into the background, and I can see higher level patterns of duplication. So these two things, removing duplication and introducing abstractions, form this little feedback loop. What that feedback loop gives me is the ability to understand what's going on in different parts of the system without having to understand the entire system in perfect detail all the time. If you've ever had that feeling where you look at code and you want to have to click into the details and then click into the details and click into the details to really understand what's happening, the problem is that there's no abstraction. I shouldn't say there's no abstraction. The abstraction's not helping you enough. You don't feel confident enough about it. The act of looking at these patterns and names, improving names over time, and looking at these patterns and names and putting similar things closer together and different things farther apart makes it easier for you to see abstractions that could be helpful. And when you introduce them into the code, then that allows you to see higher level forms of duplication. And this feedback loop helps you understand the system better. And strangely enough, if you practice this a lot, then you don't need to figure out on day one or in the first 2 weeks all the abstractions that you need. You can invent them, you can discover them as you need them, as you find that they'll be helpful. And so that's what I propose to you, is to practice evolutionary design and to use this idea of remove duplication and introduce abstractions. And introduce abstractions is a bit weird, so let me just replace it with improve names. If you focus your energy on removing duplication and improving names and doing that in short cycles, then almost like magic, the code starts to rearrange itself, to organize itself in a way that it becomes easier for you to figure out which part of the code I need to change and how to change it safely. Now, the first element of simple design was passing tests. The tests are there to make it safer for you to change the code so you can discover right away if you made a mistake. We want to reduce the time between when you make a mistake and when you see that you made a mistake, and if that time is smaller, then you'll have a tendency to spend less time, effort, and money writing code. But that tight loop of removing duplication and improving names, it's almost like a magic machine that guides the design in a direction that will be easier to understand later. Where when you need to change something, you can more easily find the part that you need to change and change it safely. That fourth element of simple design, make the design small, remove elements that you don't need. I've never needed that rule. If you remove duplication and improve names in short cycles and you do that well, it's almost impossible for the code to be too big. It's very hard to have well-organized code that is an order of magnitude bigger than it needs to be, that has an order of magnitude too many things. Almost by definition, if the code is well organized, then it's the right size. So I think you can focus your energy on removing duplication and improving names. Those rules are very simple to follow and very difficult to follow well and to master. It's a bit like learning chess. I can teach you the rules of chess in 5 minutes. Really, the basic rules take 2 minutes, and there's 2 strange rules that take a little extra time to explain. I can explain the rules to you, and you can start playing chess in 5 minutes. But if you intend to be a grandmaster and you didn't start when you were 4 years old, you're already too late. It takes a long time to master. The nice thing is that you don't have to get very far. If you focus on removing duplication and improving names, then just like the way you learn a language, you can learn the principles of design and really understand them deeply. Understand them in a way that makes it very easy for you to guide the evolution of code over time and to really reduce the cost of what it takes to maintain that code over time. Then when you try to find something because this is the part that you need to change, you'll be able to find it quickly, you'll be able to change it with confidence, and you can relax while other people are nervous. And honestly, I believe that if you really practice evolutionary design well, that will free up a lot of time and effort and energy to deal with the other annoying things that are part of building software. If nothing else, it's a stress management activity. It's a strategy for making the writing code part easier so that you can save your energy for the truly difficult parts. So now I'd like to spend a little time talking about 2 other aspects of working in software that have nothing to do with code. And I get there because, when I start working with clients, typically I sit down with a programmer or a small group of programmers and we work on some kind of programming problem. Maybe they don't like the way they've written their tests, or they've wanted to try test-driven development and they've never taken the time to do it, and I'm providing the reason for them to say, yes, I will try it today and let's see how it goes. And so we try to write some code, we try to do things, we try to understand some existing stuff, we're trying to add a feature, make some small, simple change. And within 2 hours of focusing on programming, we're already starting to talk about something that has nothing to do with code. Because I'll ask a question like, well, can't we just do it this simply? Or if it were me, and if I didn't know anything about I don't know anything about the rest of your domain or the rest of your application, but I would do it this way. And I keep proposing these relatively simple solutions. And then eventually somebody says something like, well, we can't do it that way because this person won't let us. Or we used to do it that way, but this person complained. Or we want to do it that way, but everyone's afraid of what that person is going to think. Or we want to do it that way, but we're already too busy and we don't know how to find time to do it. So I want to talk about 2 key points: organizing the work and navigating the people. And I want to give you a few little tricks that you can start using right now that will help you start to move in the direction of reducing stress in these 2 areas of your life and your work. So the first one has to do with organizing the work. Programmers complain loudly that they don't have time to do things. And that's nonsense. And I don't mean it in the way that you're thinking right now. Some of you just got very angry inside your head and said, this guy has no idea what my life is like and he's telling me I have all this time. Let me try it a different way. Stop thinking about, I don't have time. You can choose to do that right now. I'm going to give you a different way to think about it. And it's a chapter from the book Planning Extreme Programming. Yes, I'm one of those old extreme programming guys. That's how I got this gray. One of the chapter titles from the book Planning Extreme Programming hit me in the head the first time I saw it. It was simply too much to do. The idea is that when people complain that they don't have enough time, the problem with that complaint is that there is no way to create more time. The physicists, I'm sure, are working on it, but they haven't got there yet. Which means that as long as we think I don't have enough time, then you will allow yourself to be in this prison where there is no key to get out. So instead, think about it this way. You have too much to do. It doesn't seem like it actually solves a problem, but it does. Because when I tell you that you have too much to do, then suddenly there is a new option that wasn't there before. Yes, it's the silly one that you're thinking of. Do fewer things. One of the biggest problems that programmers have is that they do not have an honest picture of their own capacity to do work. The irony of software development is that everybody wants the programmers to go faster, and the programmers are almost always going way too fast already. You know what happens when you try to drive a car at 175 kilometers an hour that is not designed to go 175 kilometers an hour? If you've never done it, I encourage you to experience it exactly once. But that's what we're doing as programmers. And by the way, this is not something that's unique to programmers. It just happens to be common among programmers. So if you're in a room, not a programmer, and wondering if you can use this idea, yes, you can. But the programmers in the room, you need it more than anybody else. So I don't want to turn this into a seminar on getting things done, but if you know about David Allen's book, Getting Things Done, and you have never got around to reading it because you don't have time to, I understand. Let's start with something simpler. Let's start with something that you can use right away. I'm going to give you 2 techniques. The first one's called the 2-minute rule, and I can explain it in less than 2 minutes. The entire universe is asking you to do work all the time. Emails, direct conversations with people, phone calls for the 4 people who still make phone calls. Ideas come to your head. You're probably your worst enemy because you think of 37 interesting things to do and you don't have time to do it. Oh wait, no, I have too much to do. All these ideas are coming from all over the place. How do you manage them? Part of the problem is you probably don't manage them. You just listen to the loudest voice who most recently yelled at you. And you do that. It's not a good strategy. The 2-minute rule says that if you have an idea or some request for work comes to you, if you can finish it in 2 minutes, do it now. Otherwise, it has to go into your plan. 2 minutes goes quick. If you are not used to how quick 2 minutes is, set a timer. Trust me, it's faster than you think. It's just like being up on this stage and realizing you only have 6 minutes left. It goes by quicker than you expect. So the 2-minute rule is simple. Anything that takes less than 2 minutes, do it now because it's cheaper than planning it. Otherwise, it has to go into your plan. Where's your plan? Well, it starts with something called the inbox technique. Every programmer in this room has suffered the pain of trying to remember 97 things while they are deep in thought in a problem. And especially the young men programmers in the room feel like it's some kind of sign of strength that they can keep it all in their head. Don't do that to yourself. You're just burning brain cells. You're just destroying energy for no good reason. It's no good to anyone in your head, Mozart. Write it down. Okay, I know that movie's 35 years old, but it's a classic. Come on. All right, you all need to go back and watch Amadeus again. Have a booklet, a piece of paper, anything beside your computer while you're working. And as you're working, when thoughts come into your head or somebody asks you to do something and you're distracted, write it down, let it go, stop thinking about it, focus back on what you're doing. And when you use this technique, it's transformative. It's in a way that you wouldn't really expect. And you'll know that it's really helping the very first time this happens. You write down all these things that are coming to your head in this thing I'm calling your inbox. You get back and you focus on your task. And about an hour or an hour and a half later, you finish this task and you think, whew, I'm done. And then you look at your inbox, and there's one item on that inbox, and you go, oh, I almost forgot. No, you didn't almost forget. You did forget, and that was wonderful. This is this one little thing I need to do before I'm finished. But you know what happened for 1 hour and 30 minutes? You didn't waste a single conscious brain cell on this thing. You were able to focus on the current task, get that part done, because you felt secure that you could then look at your inbox and see if there's any little thing that you need to do before you declare victory, and then, in the meantime, you weren't thinking about it at all. You weren't wasting energy on it. You weren't trying to remember to do it. You let the paper do it. The inbox technique is just the beginning of what getting things done helps you do to organize your work. Trust me, it's very powerful, and I encourage you all to start trying to use it right now. In fact, I'm using the inbox technique right now by letting you ask questions like this, instead of you trying to remember the question you want to ask while waiting 15 minutes for me to shut up so you can ask it. Okay, now the last thing I want to talk about, and by the way, before I move on, the 2-minute rule and the inbox technique are both two little things that you can do right now, literally right now. You don't need anyone's permission, you don't need anyone's agreement, and it can start improving the way that you process work right away. The rest of the book, when you have energy, you can read it. And if you don't have energy to read 300 pages yet, then I have a 5-page guide for how to get started using the basic parts of getting things done. Once you have some of the benefits of the inbox technique, maybe you'll have enough energy to sit down and read 5 pages. You got to start somewhere. So the last thing I want to talk about is navigating the people. It'll be very interesting to see whether I can do this in 3 minutes. I grew up as one of those people who did not understand how people worked. Computers made sense, they did what I told them to do. People were these strange bags of meat that I couldn't control. My father-in-law is one of those children who in the playground at the age of 6 could convince all the other children to play the game that he wanted to play, and he made them believe that it was their idea. This is a talent I didn't have. It seems like a talent that would be useful in today's business world. If you read The Secrets of Consulting, that's chapter 3. Right? That your goal is to be able to give them advice and to walk away with them feeling like it was their idea. But I never understood how to do this. And I was in my mid-20s and I was working at IBM as a lead programmer, and people were the bottleneck. That was what I believed. Other people kept getting in the way between me and getting good work done. And I didn't really understand them until somebody taught me one tool that I can use to start understanding them better. And we start with a bad interaction, a bad conversation. You have an argument with somebody, maybe in a design meeting or a planning meeting, and you start yelling a little bit, and they start yelling a little bit, and then it gets bad. And the only thing you can think of to do after it's all over is to get out of the way, go sit in the corner somewhere, pour some wine, cry for 10 minutes, and try to figure out what the hell happened. And there's a model called the Satir interaction model, named for Virginia Satir, who was a family therapist, whose ideas were adapted to use in organizational dynamics. And she proposed this model for understanding how an interaction like that occurs so that you can try to figure out what might have gone wrong. And rather than describe the whole model, again, it's in the notes, I want to focus in on the last part. So the last 2 parts of this model are called significance and response. I just need the words so I can refer to them. Significance has to do with answering the question, why is he acting that way right now? Why did he choose to say it with those words? Why did he choose to write it with those words, say it with that tone of voice, sit in this particular way? You're interpreting what's happening. You already understand the words and you already know that you heard things clearly, but really, why did he choose to say it that way right now? And that significance, that interpretation, feeds your response, how you act. And the fundamental irony of interaction is that normally when you have a bad conversation or interaction with somebody, you are objecting to their act, their reaction, their response, and they are objecting to your actions or reactions and responses. But that's the hardest part to change. The path from significance to response, from interpreting to acting, is something that is so deeply conditioned in us culturally that we don't even think about it. It's involuntary, we don't think about it, and this is the hardest part. For us, it's perfectly rational. What I mean by perfectly rational is that if I grew up the same way that you did, with the same influences, and if I had the same interpretation of the current conversation, I would act exactly the same way. The fundamental irony of interaction is that you want to change the way they're acting, and that's the part that is the hardest for them to change. So what do you do instead? You try to find different ways to interpret what's going on. So Jerry Weinberg used to teach this, the law of three interpretations. If somebody is acting in a strange way towards you, you need to think of three different ways that they could be interpreting what's happening. And if you can't think about three, you haven't thought hard enough. So one of the ways that you can use this model is when you are in the corner crying with wine, you can start thinking about how could they be interpreting me? And try to think of three different ways that they were interpreting you. And if you can't think of three, keep sitting there until you do. Ask your friends, ask the internet, they're there to help you. The satir interaction model is much richer than that. But what I really wanted you to start to walk away with today is the idea that if you only object to the other person's reactions, that's the hardest part for them to change. If you want them to change their reaction, offer them another interpretation. Simple example, and then I'll walk away. This might be useful here. You're in a loud area where it's difficult to hear somebody. You're having a conversation with someone that you've just met at a networking event, and suddenly you do this while they're talking. And it's possible they could interpret that as you're bored and you're trying to send them some signal to shut up. But what's really happening is I'm having difficulty hearing you, and if I turn my ear towards you, then it will be easier for me to understand what's happening. I'm so interested in what you have to say that I'm willing to break eye contact in order to hear you better. So when you notice somebody getting a little bit annoyed or reacting badly to something that you're doing, consider that they are interpreting your actions in a way different from what you intend. And focus your energy there and not in telling them to change what they're doing. And if you do that, that is the starting point towards better understanding how to work with other people. I've gone over time, so I should stop. I promise that I will answer these questions at least on Twitter, and then somebody will give me a better idea where to publish them. Thank you very much for your time and attention. Enjoy the rest of the day.